This video is going to be going over how to use the Get and Augment Audio Jupyter Notebook script. The README here has a brief overview of the different functions that the script is going to be performing. It's definitely worth reading over, but we're going to be going over this a little bit more in depth. So on the left side, I will have the script as it's running, and on the right side, I have the folder that it's located in, which is also going to allow us to visualize what's happening, all the files that are being created, and all the audio augmentations as they are happening. So the first step is going to be importing all the required libraries, and then once that's complete, we're going to set these parameters. The only thing that really needs to be changed here is probably going to be your keyword. So with each keyword as you create them, you're going to want to change right here. Next, we are going to create some folders for noise and our keyword. So if you already have a noise or keyword file, then you could skip over this, but if not, run this and it will create our files. So now we have an augmented yo and a noise file. And again, I have yo here as my keyword. Next will be actually getting our custom data. We're going to run this cell, and this block is going to get 1 second of audio, 16,000 samples for that audio. So as you can see, I said nothing, so we should have noise. So now if I actually say yo, yo, we're a little off. Yo. You get the idea. Get centered. Yo. Yo. Nice. Now, if we run this block, this will save that into our augmented yo file. So I'm going to click this. We now have that audio file, yo, in there. Next, we're going to want to get, and you're going to want to do this as many times as possible in order to get as diverse of a data set as possible. So next I'm going to run this just to get the ambient room noise. There's the ambient room noise. So now I'm actually going to save this into our noise folder. So when you run here, we're going to get one noise, and then we'll do that maybe like 2 more times, probably without me speaking. So now that we have, and I would suggest maybe 3 noise files. You don't need much more than that. Ideally, you would get something base level, and then maybe like with some slight noise chatter in the background or something along those lines. Whatever your testing conditions would probably, the closest thing to your testing conditions as possible. Next, we're actually going to augment this now. So it's going to create copies of this, of our yo file, and then it's going to add in our noise to those files. So we are selecting our files here. We're basically loading in all of the files that are in this folder. And again, yo, that's our base. This is telling us how many noise samples we have, which again is 3. This is saying how many copies with that noise augmentation do we want to have. Kind of go through how this is going to work right here, but when we run this, it's going to say we have 1 audio file. It's going to create an additional 12 noise files. So because of our 3 noises, we're running it with a noise count of 4. So 3, 4 plus the original makes 13. So I use a dictionary to hold all this stuff. That way we can print it out later. We're going to run that. We now have our noise files on the right. So this is our original, yo. This is a noise multiplier of 0, so it should sound exactly the same, yo. And then a little noisier, a little noisier, yo. And then for each of those 3 noise samples, it's taking our original and adding the noise with that multiplier. So we have noise 0, noise 1, noise 2. And then this is actually going to plot them out for us so we can kind of see what it looks like. So again, we have the original. This is our noise increasing in volume. This is the original plus the noise, and this is what our output sample will look like. And this is basically just replicating what I just showed.
Yo.
Right.
Yo. Yo. Yo.
Next, we're going to do a time shift. So again, we're loading in our audio samples. In here, these 3 lines are basically creating our fake noise. This is a simulated noise, and we are running this at 1/8 of a second increments. So basically, what I'm saying is, you can, again, we're doing a time shift. So we're shifting our audio file 1/8 of a second, either back or forward in time. Down here we can set our augment count, so you're going to kind of want something similar to like a Gaussian curve, where you have your 0 shift. You want more samples with 0 shift, and then as you get more extreme, you want to have less of those samples. You do not want to have, ideally, you do not want to have many samples where the front half of your word is either cut off or the back half of your word is cut off. So more than likely, you're going to want more 0 shifts, and as you get to the extremes, the count will go lower and lower. So here I have 2, 2, 2, 1, as you can see, and then when you run this file, it will tell you how many, actually, skipped a. So when you run this, it'll tell you exactly how many you're going to create. So we're taking these 13 files on the right, and we're going to create 156 more for a total of 169. So if we run this, we now have, and you can see in the bottom, actually can't, but we now have 169 files. So if you want to plot those, see what that looks like. So this is our original. Shift to the left 1/8 of a second. Shift to the left 2/8 or a quarter, and then 3/8. And again, shift it to the right. And we can also play the audio.
Yo. 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 Yo.
Now if you listen, you can hear that sound.
Yo.
That is the noise that is created that I mentioned earlier with these 3 lines. And it's just basically doing a random jump between -200 to 200, which is, when you actually look at the graph, it looks like this right here. This is a very crude version of noise, which really doesn't sound a whole lot like noise the way you'd probably want it. So if you wanted to do a little extra, you could actually take one of your noise samples from earlier, right here, and maybe cut this into 1/8 of a second, and then instead of adding in the noise padding here, you can replace this random padding with that 1/8 of a second of actual noise, and it would probably sound a lot better. But that would be a little extra if you wanted to go through that. Next, we're going to do some pitch shifting, and I'm going to lower the file count we have in here. So now we're back down to our original.
Yo.
So again, we're going to load in the files. It'll tell you how many files you have. We only have the 1. Next, we're going to say how much pitch shifting we want to go through. As stated right here, for a positive, you're going to go to a higher pitch. For a negative, you're going to go to a lower pitch. If you want to change the amount of pitch per looping, you would decrease this value. I'm setting it to 125 files. So in the end, you're going to want something along the line. You're going to want an equal number of training data per set. So you're going to want something for yo, we'll say backwards your second word, backward, and then all your other words combined. So everything else. is going to be a third data set, and then you're going to have noise as a fourth data set. If everything else ends up being 80,000 data samples or files, you're going to want some around 80,000 backward and 80,000 for yo. You want them all to be that way. If you only have 10,000 for yo, 10,000 for backward, and 80,000 for everything else, when you train, the likelihood of everything else being selected as the result will be overwhelmingly high, because when training, that is overwhelmingly the data that it's getting. So we are going to set this to basically whatever number you want, which again I'm choosing 125. We're going to run that, and basically what it's doing now, it's running through this doubling equation. I go through the math right here of what exactly is happening, but it's figuring out how many times it needs to run through this loop in order to make the number of files that you want. So as the name of the doubling equation would suggest, every time there's a loop through, the count of samples doubles. So if we have indexes our loop count, and then we have our actual sample count on the left here. So we're going to start with one sample, just going to go to 2, going to go to 4, 8, 16, 32, so on and so forth. And then here I have color coded as the amount of pitch shift that has happened. So originally you have your original file, then your original file plus a pitch shift, your original file plus a pitch shift. Each of these is the pitch shifted version of the previous, and so on and so forth. So these 4, and then these 4 are the pitch shifted version of the second loop, and that's how that works. So we're going to run this. It also goes through, it counts and shows you the shifts that are happening here. So we now have 125. We're going to run this. This is an image. It's not as informative, I think, as the other ones, but there it is. And now you can actually listen to your pitch shifting. Ideally, you're not going to want to you're going to have somewhere in the neighborhood of, I don't know, 20, 40, a couple hundred at this point. I don't know. You might start out with 20 files, and then after running through each of those sets, the previous steps, because they're all getting progressively more aggressive in the augmentation. After this, maybe you're going to have, I don't know, a few thousand. So you're not going to be running through this augmentation to where it's going to loop 7 times. This is more for just to show you an example of it. But if you were to listen to it now, because we had a negative shift, it should get deeper.
Yo. 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 Yo.
So again, if you wanted to go higher pitch, you would change this to a positive value. Next, what else do we have? We have I'll go through this first. So I'm going to delete these yet again, just to show you what's happening. This, I didn't go through making the dictionary that way to show you the visualizations behind it, but what is happening here is we have 2 augmentations. This one is going to be increasing an audio sample, the amplitude by a multiplier, aka making it louder. And this is going to be normalizing a specific audio file to a certain amplitude. While testing, I thought maybe setting all of our audio files to have the same volume would be advantageous. However, you can do your own testing, but if I found that whenever something was said louder or quieter than this, I got very poor readings. But if we were to print out, so I just loaded in our data, right? So we have one file. I'm going to print index 0. This is what it looks like. We have about an 11,000 amplitude. If you set the noise level to 1,000, it's going to go through and set all of the audio in this folder to 1,000. So now if I replot this, 1000 is our maximum amplitude, and now instead of the previous volume level, if I run this, much quieter. This is going to multiply and increase the volume. So what I ended up doing was this instead. If you want to increase volume in steps throughout your file, you can run something like this. This is a multiplier of 5. So what it's going to do is it's going to take the file, increase the amplitude, and then just keep increasing the amplitude based off of this multiplier value. So if we, again, now we have to load in the data again because it has changed. And again, now that it's changed, it's at 1000. If I run this, now it will be progressively louder. So if we look at, this is our original file, 1000. Now we're at 2000. And if we were to run these, so now I'm looking at the next index. Now we're at 4000. Now if you wanted to, so as you can see, again, these are 4000. So if we listen to it, this is the original. This will be the original. It's getting slightly louder every time. If you wanted to, you could, I guess, make this even louder. We'll say 10. At some point, you're going to get very loud.
Yo.
Like that. And then again, if you wanted to normalize everything back down to, I don't know, we'll say 6000. We will load in all of our data again. And now there should be 46 samples. And we can run this. And now if I run any of these,
Yo.
they're all at the same audio level. So those are available to you if you need them. The last thing will be writing the augmented data to a validation file. So there is no validation file currently in here. If we run this, this is just verifying that we're reading the file correctly. There are currently 46. What this cell is going to randomize the list, because you don't want to, again, if there's hundreds of thousands of these, you don't want to add all of one augmentation, like maybe the first 1000 of your file is all just time shift augmentations. You don't want to add only those to your validation list. So when you run this, it's going to randomize, and then we are going to put them into the file. If, and you designate how many test points you want to actually put in there. So if you want to add, again, we have 46. If you want to add 10, you change that. It looks for the validation list .txt. If that's not there, it'll create it for you. So now when you go in here, we have some randomized versions of this. And additionally, if you wanted to, just to show you what it looks like, if you have a validation file that's already in there, we have pre-existing data, which you should have, because you're going to have other keywords that you're going to want to be testing against. So we're going to run this again. We added 10 yo samples to the list. And so we have our other keywords, and then we have 10 audio examples here. That is about it for this, I think. You have any questions, let me know. Otherwise, good luck.